I don't know when I made the first video of this series, but I said at some point that I would take this thing apart, and I made the first 3 parts, and then I realized that I hadn't I hadn't finished the 4th part, which was taking this thing apart. This is my own. Anker has not paid for this. It's over 2 years old now. I was gonna not do this video actually because I did search YouTube to see if anybody else had done any teardowns of these, but I've not found any good teardowns. I found people who have popped off the front and back of this thing and pulled out and show you the batteries, and that's about it. So let's take this one apart. If you're gonna take a battery pack apart, make sure that it's as discharged as possible. This is down to 2 dots. It does seem like this front cover, which is all scratched up now, these 2 do come off. And so behind them are the screws that hold this thing together. And so I was gonna try to use something that won't scratch it, but it does not seem to be working. All my other tools don't seem to want to work, and it is apparently adhesive pretty well on there, so doing it this way a little bit. Oh, look at that. That actually worked really nicely. So I'll get this front piece off because I'd like to put it back together nicely once I'm done taking it apart, if it's possible. Okay. Oh, that's actually plastic. That's actually a piece of plastic. It's not a sticker. In the other videos, they made it seem like it was a sticker, but it's, maybe I just saw it in the wrong way, but it's plastic. So there's the front of it. You can see a little, looks like they were perhaps gonna do a 3rd USB port. You can see there's a little cut there. Anyways, let me zoom back out again. And I used this one. This seemed to give me the best. This could be a little more difficult because there's nothing to pry into, like there's no port, there's ports on this side, there's no ports on this side. So we will see what. This I'm going to have to use a screwdriver, I think. I don't think there's any other way around this. If I can just get one end up. Nope. This is where I slice my finger. Awesome. Holding that in place while I get the other piece to wedge in there. There it is. Okay. Work this off carefully because I like to put it back on. Now let's take the screws off. I do like how the whole assembly is screwed together, and you can get access to the cells and inside the pack without destroying it. That is quite nice. Now you're paying a premium for that because it's 130 bucks. Sweating a little bit. I'm a little nervous about taking this battery apart. It's expensive, I like it, and I'm hoping it goes back together. I'm curious what's inside, so my curiosity is gonna would have me take this apart anyways. So yeah. So 8 screws, 4 on each side. Looks like they're all machine screws, so it's not like they're not self-tappers or anything like that, which is nice. And then maybe this pushes out. Well, it's got to push out one way or the other because I'm going to try to push out. I'm going to try to push it out from the USB ports that way. Let's push a little bit on let's push on the circuit board a little bit. Yep, it's moving. It's moving. There we go. I don't think shaking it's gonna. I thought for a second it might, and no. Does this panel come off? Oh, it does. Okay, so there's a second panel. Definitely, we're gonna put a 3rd USB port on there. Look at that. Instead, there's a choke behind it. So they must have run out of space. They even had it notched out here for that. I'm thinking they may have perhaps run out of room for the power delivery. Or maybe they do one like this, but it doesn't have USB-C. And it's just 3 USB ports? I'm forgetting. Let's keep pushing this thing out. Purple batteries. Make sure, I think that little circular button's gonna come popping out. Yep, it's gonna fall out. We'll push out this way. There it is. But you can see there are little light pipes. This is translucent. It's translucent plastic on the bottom, and then it's got the black plastic on top. So I'm sure there'll be a ring of LEDs on the other side. There's a lot of foam on this side between the batteries and the anodized chassis. This side has just a plastic, like a carrier, like they would install the batteries into the carrier and then slide it into the perhaps slide it in there. And then, look at that. This is a nice, we'll take a look at the chassis really fast before moving on to the more exciting part. Just looks like a nice anodized, I don't know what this is made of. Perhaps this is all aluminum. I think this is aluminum. I mean, it's pretty light. And there's just little rails that look like they're, oh, it's a rail. That's clever. The outer notch, so the outside of it is used to guide the battery in, and the inside is the threaded boss, I think that's what it's called, that's used for the screws. Clever. All right, so that's the enclosure. Not much more to say about that. Batteries, 8 of them. These are LG cells. And there's a screw. Okay, there's a bunch of screws holding down. I'm gonna pull the whole thing apart actually. And let's see what we can, I'm gonna take off these screws here. Yeah, these are LG cells. Interesting. So Anker must source from a variety of, I'd imagine they'd source from a variety of companies. I like that there is this cap or cover, and maybe it's just for shock, like so the batteries can't move around. All right, let me keep my screws straight here because these are self-tappers. Circuit board looks pretty nice. Let's keep taking it apart and see what we can find here. So I released the piece that holds the batteries down. I released 2 more similar self-tapping screws just like these 2. And I think that's all that holds this whole thing down. Maybe we can get the batteries to come out. The circuitry, the meat and potatoes here. Let's see what we've got. Cool. Cool. So it's a whole plastic. Wow, they did a nice job on this thing. So it was a whole plastic chassis that the batteries sit in, and then I think also forms there's a little plastic feature that provides the facility for the button, like between the actual surface mount button and then between the plastic transfer to the outer case, which then this sits inside of and lines up like that. Nice. Circuit board is dated October 19th, 2016. We'll look at the batteries later. Let's look at the circuit board first. It's like a daughter board that sits above the main board for that light ring. What do we have? Okay. So it's not, this is actually arranged in it looks like it is arranged in an 8.4 volt configuration. So 2 cells in series, and then 2 series, 4 parallel. There's battery minus down here, battery plus up here, across the 2 cells, and then there's a balancer in between. Battery BP, which I believe is battery protection, to see if there's any imbalance across these cells. And then it just would balance out each half of the cell. So I don't know what this is called, the Celastic. I've heard it called that, whatever, like on all the connectors and stuff to make sure that nothing comes popping apart around this inductor. And I think around this choke. In this choke. And this choke, I believe, is for the boost output, because this can charge at 20 volts is the highest output voltage it can do. And so it's 8.4 volts maximum. Nominal is what, 3.7 times 2. Let's get the voltmeter out real quick and take a peek. We'll do the halfway point first. 3.39. I would say for only 2 dots left, 3.39 is actually kind of high. I would think it would have gone down a little lower. There's a shield on the back here. Oh, he soldered that in place. That's the switcher. I'd rather not take that apart because that would require desoldering it. Not going to be easy to get off of there. This is a heat sink, and it's mechanically bonding it. I think it has like a heat transfer pad. So the switcher sits behind there. I think that's for the boost conversion going out, because there's no boost conversion going in, because this just bucks to, you know, whatever the input voltage is. Well, actually, I take it back. It may have to boost because I think you can charge this at 5 volts. But I wonder if it changes the power flow direction based on whether it's receiving charge or it's providing charge, and uses the same boost topology for both, because I don't see 2 sets of boost circuitries. So I suspect that this circuitry is bidirectional. Negative to positive. 6.8 volts. So 3.4. Yeah, okay, so they're pretty well balanced. It's doing its job. Anker definitely wants you to know that they made these boards, because their name is on it. Silkscreen right on there. Interesting, this button board is from 2016-10-19, version 1.0. And below it, I don't know if you can see it, but below it, this is from March 20th, 2017. And it's A1375A version 1.4. The only thing I don't see, which is a little bit disappointing, is I don't see any thermal protection on the battery. I don't see any temperature sensor down buried anywhere around the cells here to detect if there's an over temperature situation. This is a really clean board. There's a little bit of flux here from when stuff was hand soldered, but it's very minimal. It's a very clean board, and just helps these things last even longer. I mean, that's the main point. So yeah, this is well designed. I'm impressed. Oh, there are 2 little controllers. They are hidden underneath that, because I'd like to pull this off and show the little controllers. Now, this is all still plugged in, so I do not want to short anything out. He says as he shorts something out. No, I didn't. Let's stay with plastic things. There we go. So this should come off now. Might be a little bit. There we go. It's coming off. I don't know what the pitch on those are, but they are really, really, really close together. But neat. I mean, you need a lot of them, because you need to be able to address each one of these little LEDs. Get the celastic out of there. So this is just soldered to the top of the battery. I'm not really super psyched about that, but if it were to come loose and touch something, well, it could short the battery out on this side. My preference is to see what they did with battery minus and battery plus. What they did is they put the wire through the hole and soldered it on the opposite side. So it's mechanically secured through a hole and then soldered on there. So you can, even if the solder joint were to float on this side, you couldn't pull the wire back out. So it's a nice securement method to make sure these batteries don't short. The batteries do feel like they're really stuck well to one another. They don't feel like they want to move around very much. Might just be the tape they're using. Got the fish paper, just like I showed on the RAV Power battery, that provides additional protection for the various tabs. The positive tab is just kind of wrapped in just masking tape. That's okay. And the negative tab, same thing. It's just got a little bit of masking tape on it. I prefer the fish tape, but it's better than not having it. And then they use some packing tape, strand tape, just kind of keep this wire in place and this wire in place. I'll look up the batteries, and I'm going to look up these things with the microscope, and then we'll come back and we'll chat about that and wrap things up. Well, I had a little poke around on the interwebs and can't really find this LGAB F1L1865 battery that matches what the nameplate shows. 2 series, 4 parallel, 2S, 4P. And then it has 26,800 milliamp hour. I don't know what 900 means. And then it has a serial number, it looks like. And it has an LG reference, LG3350. So I'm wondering if LG made this for Anker, and then they just, you know, it's some internal cell thing. What I will say is that the cell that the Google thinks that it's closer to is this LGAB F1 18650 whatever, and it looks like that has a data sheet. So it's 3350 milliamp hour per cell, and if you multiply that by 8, that brings us right up to 26,800. So here is the LG Chem spec. They have a different reference for it. This INR. Well, that's just, I think that's just the style of it. 18650. I don't know what INR means. And F1L. But if we go and look, let's see. Is this 33? Yeah, minimum 3250, nominal 3350. The nominal voltage is actually 3.63 volts, a little lower than 3.7 average. There it is there. It's showing the model number, and it's everything the same except for LGAB instead of LGAB. So I don't know what that means. After 300 cycles, 75% of its initial capacity. Interesting. High temperature storage, high humidity, high temperature, thermal shock testing, cool, drop test, vibration test. These are all the tests they do for standard UL. Yeah, here we go, UL 1642 testing. Pretty nice set of cells. And it kind of goes along with what we were seeing with the capacity after 18 months. It had to be at least a couple hundred charge cycles, and it was actually a little bit above what this testing was showing. What I was going to check lastly is these suckers. So these 2 chips on the board, and let's look at the first one. Let's look at Southchip first. So Southchip SC880. Let's see if we get anything on that. Southchip SC880. 2QDER. I think the more we go into this, the less like we're going to find something, but let's see what we get. Here we go, SC8802. I think that's what it said. It's SC8802, high efficiency synchronous what? Buck boost converter? What is it? What is it? What is it? The excitement. If it ever loads. Getting there. Getting there. Look at that. It actually confirms what I was talking about before. Yay for me. SC8802, high efficiency synchronous bi-directional buck boost charger. Holy cow. That is definitely worthy of a little chip doing a lot of work. 4 switch buck boost charger controller. It is able to effectively manage charge no matter what the input output voltage is higher, lower, or equal to battery voltage. When system needs to discharge the battery, it will deliver desired output from the battery without extra efforts. Wow, it's got a, look at this, buck boost battery charging, supports 1 to 6 batteries in series, 1 to 6, wow. Trickle charging, constant current, CV, charge termination, reverse buck boost. This is confidential, by the way. Wide input voltage range, 27 volts to 30 volts. Wide reverse operation voltage range, so that it's discharging and charging. 2 volts to 30 volts, dynamic. Wow, that is a really cool chip. Wow, look at that. Wow, you get more efficiency. Wow, wow. So if you charge this thing at 5 volts, even up to 2 amps or 3 amps, that's where your highest, the 5 and 9 volts, where your highest efficiency is. I'm sorry. That's discharging efficiency. So yeah, that, I was like, how do they make that happen? How does it, it's bucking. So it's bucking at 5 volts, it's bucking at 9 volts. No, it's just kind of in between buck and boost at 9 volts. 12 and 20 it's boosting. So that's where we saw in our previous videos back where the 20 volt was somewhere around, I think we saw 80% efficiency overall. And this device itself, its efficiency with its stuff is about maybe 92, 93% efficient. Cool. And you get it to the 5 and 9 volts and you're up into the 97, 98% efficient. That's pretty damn awesome. Typical application circuit. You can see that bi-directional. Low charging, high discharging. It's got a full H bridge here, looks like. Wow. A lot of stuff going on in there. Really cool. Let's look at the other one real quick. And that other one is CYPD 2122-B. -B. Let's see if we can get something. Monitoring of the council's revenue budget agenda. No, that's not going to help me. 2212. Oh, Cypress something. Oh yes. I think we found ourselves a little microcontroller. 32-bit. What? Jeez. Why? That's crazy. CYPD 2122. CYPD 2122-B. Oh yeah, there's no dash there. I put a dash in between the CYPD 2122. There's no dash. Let's look at the data sheet in English and see what we got here. Oh. Okay. USB Type-C port controller. So it is. Wow. There's a lot of computing going on inside this battery pack. Holy crap. It has Cypress proprietary MOS8 technology with a 32-bit 48 megahertz ARM Cortex M0 with 32 kilobytes of flash and integrates a complete Type-C transceiver, including the Type-C termination resistors, R sub P, R sub D, and R sub A. Wow, it's programmable, so they probably use all of that for the lights lighting up and all that stuff. And I wonder what does the gas gauge, the little ring like management, if they program that themselves. It makes sense now why I did notice on this, there's a little programming header right here. It's a header that's been either like pogo pins pop down on this thing, but like they pogo pin this and then flash that chip. Look at that, 32 kilobytes of flash, 4K of SRAM, 8K of SROM, USB power delivery subsystem. So it has that subsystem right built into it, so they're not writing anything. Wow. I'm just kind of curious. So I think I'll link to both these data sheets in the description because this could go on. I could go on for hours. But the one thing I was curious about is just like power consumption. Let me just search on power consumption, see if we can find something. Low power operation, 2.7 volt to 5.5. Sleep is 2 milliamp. Deep sleep is 2.5 microamp. I'm imagining this is in deep sleep when it's not being used. You'd hope. Electrical specifications, page 19. I can handle up to 6 volts. 2.2 kV static discharge. Wow, they can actually do, and then on the output, it's 8 kilovolts and 15 kilovolts on that chip itself out the USB port. That's, wow. If I read that right, I'm pretty sure I did. Contact discharge on CC1, CC2, VCON1, and VCON2 pins. And I'm pretty sure, if we go all the way back up to the, VCON1, VCON2, that's all that's the power delivery stuff. So the power flow that's being managed by the other chip for buck boost and all that has to have its own electrostatic discharge and all that protection. But the chip itself, within that data logic stuff that's coming in, has pretty impressive ESD protection. I will get these two data sheets on the description of this video so you can peruse them at your leisure. The batteries are great. I'm confused as to why it's a special non-Google searchable part number, but it looks like this might be a pack that LG makes for Anker, and this pack arrives at Anker, and Anker just solders it on and does the final assembly. So could explain why this has its own little part number reference. And this one I've had for 2 years, and it still is, I can still use it with my laptop. It still charges and is, I haven't noticed any change since I tested it before. So 2 years in, and these cells are still doing a great job. It's all in pieces, and now I got to put it all back together. But the other awesome thing about this is that I can take this whole thing apart, and while Anker doesn't sell any of these, you can't go to Anker and be like, hey, give me this piece of plastic. They're not going to give that to you. But I at least can open this thing up, and when these cells start to really fade, I can open this thing up very carefully and order replacement cells for this and not throw all this stuff out. I can recycle the cells, put the whole thing back together again. I probably could even find, we would sell a pack in this configuration. And it might be, I don't know, 4,000 milliamp hour per cell. And then you have even more capacity. And then so long as that matches the voltage and the configuration that this is currently in, that is 2 series 4 parallel, it'll keep on working. I really hope you enjoyed this video. Give you an inside look at what's going on inside your Anker. At this point, I don't even remember what this thing is called. What is it called? I think it's on this plate. The Anker PowerCore Plus 26800 with USB-C power delivery. Model A1375. Until next time, take care.